Assalamualaikum. My name is Wan Kashifa Arifah binti Wan Muhammad Janatul Adni, and I'm going to present the first scenario related to a second-order linear homogeneous differential equation. This scenario involves an undriven LC electrical circuit, which we will analyze step by step. We are given an ideal LC circuit that contains an inductance equal to 1 Henry, a capacitance equal to 0.25 farad, no resistor, and no external voltage source. We are also told that the initial charge on the capacitor is 3 coulombs. The initial current in the circuit is 0 amperes. In an ideal LC circuit, the charge Qt on the capacitor follows this differential equation. L multiply D2Q dt square plus 1 over C multiply Q equal to 0. Substituting L equal to 1 and C equal to 0.25, we will get D2Q over dt square plus 4Q equal to 0. This is a second-order linear homogeneous differential equation with constant coefficients. Now we solve D2Q dt square plus 4Q equal to 0.
Assalamualaikum, my name is Shafiqah binti Hasan and I will explain this part. Before this, my friend already defined the second-order linear homogeneous differential equation with constant coefficient. Now let's solve it step by step. We start by finding the characteristic equation, which is r squared plus 4 is equals to 0, r squared is equals to -4, r is equals to plus minus 2i. This gives us complex conjugate roots, so the general solution is Qt is equals to C1 cos 2t plus C2 sin 2t. Now we apply the initial conditions to find the particular solution. We are told the mass is pulled down 3 meters. This gives the initial position Q0 is equals to 3. It is released from rest, meaning the initial velocity is 0. From the general solution, we will differentiate it and we will get negative 2C1 sin 2t plus 2C2 cos 2t. Okay, we apply the initial conditions. At t is equals to 0, the position of C1 is equals to 3 at the end. You can see it by yourself. We substitute the value of t is equals to 0 into the equation, and at the end we will get C1 is equals to 3. Same goes to when we substitute the value of t is equals to 0 to the velocity, and at the end we will get the value of C2 is equals to 0. Now we substitute the value of C1 and C2 back into the general equation, and we will get Qt is equals to 3 cos 2t. Okay, the last one, we will find when the capacitor first discharged. To find when the capacitor first reach 0 charge, we solve 3 cos 2t is equals to 0. After that, we divide both sides with 3. We will get cos 2t is equals to 0. We solve it. We will get 2t is equals to pi over 2. T is equals to pi over 4. And the final answer is 0.785 seconds. So the capacitor first discharged at approximately 0.785 seconds. And that's it. Thank you.
Hey everyone. Today, I will explain about the second-order linear non-homogeneous differential equation. Let's look at the scenario. Car suspension system with damping experiences periodic force due to root pump. The system parameter R give us mass M equal 1 kg, damping coefficient equal 3 Newton second per meter, feeding constant K equal 2 Newton per meter, external force amplitude F naught equal 5 Newton, and regular frequency omega equal to reading per second. This is the situation we are going to shoot today. You can see here, the car is moving and the root bump is causing an external force. Next, based on the scenario, the mathematical model for the system is m times d squared y over dt squared plus c times dy over dt plus k times y equal f naught constant omega t. When you can write the differential equation based on the given parameter, the equation is d squared y over dt squared plus 3 dy over dt plus 2y equal 5 cosine 2t, where m equal 1 kilogram, c equal 3 Newton second per meter, k equal 2 Newton per meter, f now equal 5 Newton, and omega equal 2 reading per second. Thank you.
The general solution for non-homogeneous linear equation is y equals to yh plus yp. So it is the sum of complementary function and particular solution. So for the second step is solve for complementary function, same as the solution for homogeneous differential equation, which is d2y dt squared plus 3 dy dt plus 2y equals to 0. To solve that, we set up the characteristic equation for m squared plus 3m plus 2 equals to 0 that ends up being quadratic equation. So, the roots that we get for this equation are m equals to -1 and m equals to -2. YH is the complementary function, so we just substitute the value of m that we get into that equation. Our complementary function is C1 exponent negative t plus C2 exponent negative 2t. The third step is solving for particular solution. So Yp, which is the equation for particular solution, equals to A cos 2t plus B sin 2t. After that, we differentiate the equation of Yp by using chain rule to get the first derivative and the second derivative. Plug the equation of Yp prime and Yp double prime into the equation of d2y dt square plus 3 dy dt plus 2y equals to 5 cos 2t. So, that is the equation that we get after we substitute all the equation. After that, we expand and simplify the equation. As we can see, we get the same terms, which are cos 2t and sin 2t. So, we factorize cos 2t and sin 2t. The equation that we will get is cos 2t in bracket negative 2a plus 6b plus sin 2t in brackets negative 6a minus 2b equals to 5 cos 2t.
So for step 4, solve the system of equations. So the equations that we get from the previous step is cos 2t in bracket negative 2a plus 6b plus sin 2t negative 6a minus 2b equals to 5 cos 2t plus 0 sin 2t. So by comparing both sides, we get negative 2a plus 6b equal to 5 for equation 1 and negative 6a minus 2b equals to 0 for equation 2. So here, we multiply equation 1 with 3. So we get negative 6a plus 18b equals to 15. Then we minus it with equation 2. So we get b equals to 3 over 4. Then we substitute b equals to 3 over 4 into equation 2. So we get a equals to negative 1 over 4. Then the particular solution is negative 1 over 4 cos 2t plus 3 over 4 sin 2t. Next, step 5. Write the general solution. Y is equals to YH plus YP. YP we already obtained from the previous step, which is negative 1 over 4 cos 2t plus 3 over 4 sin 2t. Then YH is equals to C1 exponent negative t plus C2 exponent negative 2t. Then we substitute it into Y. So we get C1 exponent negative t plus C2 exponent negative 2t minus 1 over 4 cos 2t plus 3 over 4 sin 2t. The initial condition is 0, so y0 equals to 0 and dy dt 0 equals to 0. Then we substitute t equals to 0 into the equation. So we get y0 equals to c1 exponent negative 0 plus c2 exponent negative 2 0 minus 1 over 4 cos 2 bracket 0 plus 3 over 4 sin 2 bracket 0. So we get c1 plus c2 minus 1 over 4. Then we rearrange it. We get c1 plus c2 equals to 1 over 4. So it is the first equation. So y prime 0 equals to 0. Then y prime 0 equals to c1 exponent negative t minus 2c2 exponent negative 2t plus 2 over 4 cos 2t plus 6 over 4 sin 2t. Then we simplify it and we get c1 exponent negative t minus 2c2 exponent negative 2t plus 1 over 2 cos 2t plus 3 over 2 sin 2t. Then we substitute t equals to 0 into the equation. Then we get y prime 0 equals to c1 minus 2c2 plus 3 over 2. Then we rearrange it and we get c1 minus 2c2 equals to negative 3 over 2, which is equation 2. Then from equation 1, c1 is equal to 1 over 4 minus c2, and it is equation 3. Then we substitute equation 3 into equation 2. Then we get negative 1 over 4 plus c2 minus 2c2 equals to negative 3 over 2. Then we get c2 equals to 5 over 4. Then we substitute c2 equal to 5 over 4 into equation 3. Then we get c1 equals to negative 1. So the complete solution is y equals to negative exponent negative t plus 5 over 4 exponent negative 2t minus 1 over 4 cos 2t plus 3 over 4 sin 2t. That's all. Thank you.